must also consider that everything, including man, must function in zero gravity. Weightlessness adds many design problems we have never faced before. The problem is complicated by the fact that it is extremely difficult to produce a truly weightless environment on Earth. Parabolic flights in a jet aircraft provide less than a minute of test time per maneuver. Research scientists have been able to extend test times by developing an underwater technique that in some respects simulates weightlessness. Another device, the free space simulator, approximates the difficulties encountered in doing useful work in zero gravity. In space, it will be virtually impossible to apply a twisting, pushing, or pulling force without something to hang on to. Our spacecraft designs must reflect an understanding of these problems and provide for them. In order to regulate the operation of all systems in a spacecraft, we must provide a reliable system of instruments and controls. Many of the controls will be automatic. Others will require manual operation. Status lights will indicate the general operating conditions of all systems. This will minimize the amount of attention the crew must devote to monitoring and control. In instances where fluctuations of a temperature, pressure, or process event are critical, a warning signal directs the attention of the crew to the trouble spot before it becomes a serious threat to their safety. Crew safety is all important. The success of a mission is dependent not only on the crew being safe, but feeling safe. Safety must be built into the life support system. Critical components will have backup units that can be switched into the line if needed. For example, in this prototype, the water recovery system has 2 distillation units. If one fails, the other can maintain the normal supply of drinking water and half of the wash water allotment. If both distillation units fail, an emergency unit using special filtration techniques will purify exhaled water vapor and perspiration condensed from the cabin air. Under these conditions, the crew will use water for drinking and food preparation only. Also, there will be an additional emergency supply of water. The oxygen recovery system has 2 reactors in case one fails. If both reactors fail, the poisonous carbon dioxide would be discharged overboard. The crew would then draw oxygen from an emergency supply while making repairs. In the case of serious atmospheric contamination or loss of pressure within the spacecraft, crewmen will get into their pressure suits and connect directly with the spacecraft's atmospheric control system. The suits are also equipped with their own cooling system, pressure, and oxygen supply, allowing the crew to work independently of the spacecraft life support system. Sustaining man in space for long periods of time presents enormous challenges to present-day technology.